The specter of an electromagnetic pulse, or EMP, is no longer confined to Cold War-era fiction. Experts across defense and intelligence agencies concur, it is a tangible threat shaping modern military strategy. A high-altitude detonation of a nuclear device, or even a sophisticated conventional EMP weapon, could generate a massive electromagnetic field. This pulse, according to a 2019 report by the EMP Commission, has the potential to disable unprotected electronics across continent-sized areas. The Pentagon is not just considering this possibility, it is actively preparing for it, focusing on ensuring its core command and control structures remain operational. The civilian infrastructure remains alarmingly vulnerable. The EMP Commission estimated that within 12 months of a widespread EMP event, up to 90% of the U.S. population could perish due to societal collapse stemming from a lack of food, water, and medical care. This catastrophic scenario is precisely what drives the Pentagon's focus on its strategic assets. While civilian hardening efforts lag, the military's mandate is clear: maintain strategic retaliatory capabilities. This means ensuring that crucial systems can function autonomously, isolated from a potentially defunct national power grid and communication networks. In response to this existential threat, the Pentagon has quietly initiated a rapid upgrade of its most critical command centers. Sources within defense contracting firms, who spoke on condition of anonymity due to classification concerns, indicate that these upgrades go far beyond standard stormproofing. The objective is to create islands of resilience within the military's strategic network. This includes not just physical hardening but also the integration of next-generation EMP shielding technologies. The focus is singularly on preserving the chain of command and the ability to project power, even if the world above ground faces total technological blackout. Traditional EMP protection often involves Faraday cages, conductive enclosures that block electromagnetic fields. However, next-generation military shielding, according to engineers involved in classified programs, integrates far more advanced materials. This includes proprietary alloys, multi-layered composites, and even active cancellation systems that can detect and counteract incoming EMP surges. The goal isn't just to block the pulse but to manage residual energies, preventing damage to sensitive components. These bespoke solutions are a stark contrast to commercial off-the-shelf shielding, tailored to protect against specific threat profiles, some of which remain highly classified. EMP pulses can induce currents of hundreds of kilovolts per meter, frying conventional electronics instantly. To combat this, the military is deploying hardened electronics. This involves radiation-hardened components, which are designed to withstand extreme electromagnetic interference. Furthermore, a significant shift is towards optical fiber networks, which transmit data using light pulses instead of electrical signals, making them inherently immune to EMP effects. Analysts estimate that investment in hardening individual components and replacing copper wiring with fiber optics has seen a budget increase of over 300% in certain strategic programs over the past 5 years, according to a recent unclassified GAO report. Facilities like the Cheyenne Mountain Complex, home to NORAD, represent early precedents for EMP hardening. However, current upgrades extend beyond these iconic bunkers. The strategy now emphasizes a distributed command and control network, leveraging multiple, smaller, equally hardened facilities rather than relying on a few large targets. This redundancy, defense officials assert, increases survivability. Unofficial estimates suggest that the number of highly hardened command nodes has increased by approximately 40% since 2015. Ensuring that if one node is compromised, others can seamlessly take over critical functions to maintain strategic awareness and response capabilities. Ensuring these systems work isn't left to chance. The U.S. military utilizes advanced EMP simulators, such as those found at Kirtland Air Force Base, to test the resilience of new technologies and existing infrastructure. These facilities can replicate the intense electromagnetic fields of an actual EMP event, allowing engineers to identify vulnerabilities and validate shielding effectiveness. It's a continuous cycle of threat assessment, design, testing, and refinement. Sources indicate that critical strategic assets undergo annual EMP resilience tests, a protocol that has reportedly reduced system vulnerabilities by 25% over the last decade, proving the efficacy of these rigorous evaluations. The disparity between military and civilian EMP preparedness is stark. While the Pentagon invests billions, hardening strategic assets, the broader national infrastructure remains exposed. The military's systems are built to withstand pulses of hundreds of kilovolts per meter, whereas average civilian infrastructure is typically protected against only small surges, often less than 1 kilovolt. This creates a critical vulnerability for the nation, even if the military's command structures survive. The military's focus is on maintaining a retaliatory strike capability. The larger issue of national recovery falls to other agencies, which lack comparable funding or mandates. In the evolving landscape of conflict, EMP weapons represent a physical layer of cyber warfare. Unlike software viruses, an EMP attack doesn't target data, it targets the very hardware that processes it. It is, in essence, a kinetic cyber weapon. This makes traditional digital defenses irrelevant. The Pentagon's focus on EMP shielding is therefore an acknowledgement that future conflicts may not be limited to digital networks but could involve attacks designed to physically dismantle the technological backbone of an adversary. It's a preemptive move to ensure that even if the digital battlefield is compromised, the ability to respond physically remains intact. The ultimate purpose of these extensive EMP hardening efforts is to safeguard the U.S. military's strategic retaliatory network. This encompasses the command and control systems for nuclear deterrence, long-range conventional strike capabilities, and critical intelligence gathering assets. If the national power grid were to go dark, the ability to launch a counter-response, or even simply understand the unfolding situation, relies entirely on these hardened systems. It's a complex undertaking, involving redundant power sources, secure communications, and, most critically, the physical resilience to absorb an EMP strike and continue functioning with minimal interruption. The classified nature of many of these programs presents challenges, even to oversight. Details about specific technologies, their deployment locations, and exact hardening levels remain highly guarded secrets. While this secrecy is deemed necessary for national security, it also limits public discourse and independent verification of effectiveness. Some critics argue that the lack of transparency could lead to inefficiencies or undetected vulnerabilities, though defense officials strongly refute such claims, emphasizing rigorous internal testing and independent validation within classified channels. The balance between operational security and accountability remains a persistent tension in these high-stakes preparations. As global adversaries develop increasingly sophisticated EMP and cyber warfare capabilities, the Pentagon's investment in advanced shielding and hardened electronics is not just proactive, it's a strategic imperative. The goal is to ensure that even in the most catastrophic scenarios, where the national power grid fails and conventional communications are silenced, the U.S. military's strategic retaliatory network remains a viable deterrent. This isn't merely about protecting equipment, it's about preserving the decision-making authority, the communication channels, and the physical means to respond, ensuring national security in an era where the lights might quite literally go out.